Hey, thank you for joining us for the retest review on properties of logarithms for Module 2A. So, in the first question, you're going to write each logarithm as fully condensed or single fully condensed or single logarithm and then simplify. All right, so what we have to do is use our properties of logarithms to simplify our items. Now, what are our basic properties of logarithms? Well, we know that if I have a logarithm of some base of a, right, divided by c, right, so if I have that, that'll become log base b of a minus log base b of c, right, and if I have log base b of a times c, that can become log base b of a plus log base b of c. Right? And then our exponent property is going to be that if I have, right, a logarithm base b of some a raised to a power, that can become n times that logarithm base b of a. Right? So for this problem on the left, we noticed that our base is 3. We noticed that we have subtraction, so I'm going to be using this division subtraction property. And so this is going to be log base 3 of 10 divided by 5, which would be log base 3 of 2. All right, over here I have the division property, but I also have the power property. So I'm going to rewrite this first as the natural log of x plus 2 to the 1/3 power minus the natural log of x, right? And then that's going to be equivalent to the natural log of, I'm going to have the cubed root of x plus 2 all over x. All right, so I have the power property and the division or subtraction property. Continuing with the next example, right, we have 1/2 log x, right, and so I can say that this is going to be log x to the 1/2 plus log x plus 1 to the 3rd power, and addition is going to relate to multiplication, right, which would be this setup here, and so that's going to be the logarithm, the implied base is 10, of the square root of x, x to the 1/2, times x plus 1 to the 3rd power. Okay. We look at D, right? We have our bracket and we have our coefficient out to the front. And so I could rewrite this as log base 2 of x to the 1/3 power plus log base 2 of x plus 1 to the 1/3 power if I wanted to. But really, it'd be easier to think about this as 1/3 times log base 2 of x times x plus 1, right? And then from there, be able to say that my single logarithm is going to be log base 2 of a cubed root of x times x plus 1. And that would be my solution using properties of logarithms. So that's condensing logarithms. If I'm going to expand logarithms, all right, then I can look to this first example. I have a product of 3 things. So this is going to be log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. And I want to fully expand, so I need to take my powers and use the power property. And I'll have log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. All right, so there's my fully expanded. For part B, I'm going to have the natural log of 3x minus 5 to the 1/2 power because of the square root minus the natural log of 7, and then that's going to be equivalent to 1/2 the natural log of 3x minus 5 minus the natural log of 7. Okay. Continuing, if I look at C, I have log base 4 of x times y minus log base 4 of z times a to the 1/2. And then to expand this further, that's going to be log base 4 of x plus log base 4 of y. And then I'm going to have minus log base 4 of z minus 1/2 log base 4 of a. All right? And I have to remember that this negative is going to end up distributing to each of those terms, right? That really what we have is minus log base 4 of z plus 1/2 log base 4 of a, right? And that negative will distribute to each of those terms, which is why then we have a negative and a negative for both of those terms. And lastly, we have our expansion for this particular one. We'll say log of x squared plus 1 to the 1/2 power minus log of x cubed minus log of x plus 1 to the 4th power, using that same property of distributing the negative. And then using our power rule, that's going to be 1/2 log of x squared plus 1 minus 3 log of x minus 4 log of x plus 1 to the 4th power. So there we have with our properties of logarithms. So that's using properties of logarithms. It's important to understand. You need them when solving equations and in other areas of applications of mathematics. So you can condense logarithms to get to a single logarithm, or you can expand logarithms to larger expressions. But please be familiar with both. Thank you for your time.